You've got clean data, but that's not it. It's still a set of disconnected tables. In order to unlock real insights, you need to build a reliable structure wherein all the data work together. Hi, I'm Niveda, and welcome back to Chapter 3 of Star Agile's Power BI course. If you're joining us for the first time, I highly recommend you to watch the previous 2 chapters, as it will lay a strong foundation and also help you understand the very first process, which is data extraction and transformation. Today, we are diving into data modeling. Data modeling is the heart of Power BI. We are going to understand about different types of tables like the fact table and dimensional table and how to connect them in order to produce a powerful star schema using our fuel bunk example. By the end of this chapter, you will know how to build a robust data model that is logically structured in order to make powerful insights possible. Okay, so let's get started. Now, we are at the phase of data modeling. Data modeling is nothing but the heart of Power BI. The reason why we call this is because for your interactive dashboard to be accurate with its number, you need to make sure that all the tables in your model are well connected, right? So why do we have to connect? The reason being that, think about your fuel bunk. There are a lot of transactions that happens on a daily basis, even when it comes to your dip table, your stock table, your shift reading table, your cash and expenses table. These tables are continuously growing every day, isn't it? It becomes important for you to record these dynamic transactions on a day in and day out basis. And it is recorded using fact tables. They're called as fact tables because it consists of the facts or the numbers. Now let us understand the 2 different types of tables. As I mentioned earlier, fact table consists of numbers, but numbers alone can be very overwhelming, which is why you need to add context to it. Now, what do I mean by context? Now, let's say I need to find what is the sale that happens in this diesel type of fuel. So here I have the fuel type information in one place and I have the sales information in the shift table. So let me tell, I want to determine the location-wise expenses. Or if I want to see a daily trend when it comes to fuel rate. So in order to answer these questions, I need to have context to it, which is why dimension table adds context to the information that is present in the fact table. Fact tables are called as quantitative tables and dimensional table are called as qualitative tables. This contains the description. So consider this simple example, guys. So let's say you have the location information, right? So let's say I want more information pertaining to the city. Like for example, which state it belongs to, what is the exact address, who is the store manager, etc. So these are the descriptions that describe about the Bangalore. Am I right? So if you have to add these additional information in your fact table, just imagine how lengthy or how wide the fact table will look like. Already with your facts in place, the table is going to look lengthy. Reason being that it's growing every day. So fact tables are ideally supposed to be a long table, and your dimensional tables on the other hand are supposed to be wide in nature. Reason being that if I have location related information, I may have the ID of the location, I may have the store information of that location, the address and the manager details. So generally, dimension tables don't be as lengthy as that of your fact tables, and also they don't change over the period of time until and unless there is a new store in place. So this differentiation is very much essential, which brings us to the new concept of understanding primary keys and foreign keys. Now, as I told you, dimension table consists of IDs, these IDs are essentially unique values, which means there is no sense in repeating these IDs over and over again in your dimension table. Also, this ID can refer to the multiple entries of your fact table, isn't it? Because Bangalore can have different types of fuels. Hyderabad can again have different types of fuels. So, this distinction is very important. Hence, your location consists of primary keys, which are the unique keys, and it references to the foreign keys of the fact table. That's the difference between primary key and a unique key. Dimension table consists of primary key, which is unique, and fact table basically consists of foreign keys which are referenced by the primary keys. So ideally, in our example, we have fact tables that is already loaded in the previous chapter, which is dip, stock, shift reading, expenses, and cash collection. Additionally, we'll be having 3 other dimensional table, which is a calendar table, fuel info table, and location table. So these tables are basically created in order to answer these questions. Calendar table basically consists of the dates starting from the time the dip measurement was taken. And we are also going to make this calendar table an automatic dynamic table, which gets added as and when a dip entry is added. Similarly, we are going to add a fuel information table which consists of various types of fuel and also their naming convention. Next, we are going to add the location table. Location table can have store related information, ID information, and of course location information. Please make sure that the common columns are present in your dimensional table as well as fact tables. So, to summarize the differences between the fact table and the dimensional table, if you look at the PPT, it stores measurable quantitative values, whereas dimensional table stores descriptive and qualitative values. Fact tables are mostly numbers like your sales, liter, expenses, cost, and so on. Whereas your dimensional table are text and categorical information. Fact tables are very detailed because it is transactional level records, wherein your dimensional table are high level descriptive attributes. Fact, as I said, continuously grows with new transaction, whereas your dimensional table, the transaction does not happen on a daily basis. Fact tables consist of foreign keys and dimension table consists of primary keys. This can also be a very important interview question if you are a beginner or a mid-level Power BI developer. So now that we have our fact tables in the picture, let's try to bring in the dimensional tables. So as we discussed, we have 3 dimension tables, isn't it? So here I have stored the fuel dimension table and the location dimension table in my local system in the form of Excel sheets. So let us try to pull that into our dashboard. And how do we do that? You just have to go to the get data, you can go to the Excel, and you can go to the path where you have saved the materials. So in my case, I'm going to first pull in the fuel dimensional table. It's going to take some time. And there you go. So here you can just preview the elements. So I'm going to directly import this. I'm going to load this because there is no transformation as such. It's a very small dimensional table. And now the rows are loaded. So as soon as the table is in place, you can see towards your right side that it is created. I'm going to quickly rename this as the fuel info table. Got it? Post which I'm going to bring in another table, go to the home tab, get data, Excel workbook, and go to the location dimension table. So this consists of the location information. So again, I'm going to preview it. I have the location ID in place, city, the manager, and the place. And now I'm going to load the same. And quickly rename this as the location table. So for renaming, you can just directly right click and choose rename. Just in case if you have imported a wrong table, then you can go ahead and delete from the model. So in my case, I'm going to rename it to location. Make sure that everything is caps. All right. And now we have to import the calendar table. With respect to the calendar table, guys, I've told you earlier, I want the calendar table to be a dynamic table, isn't it? So we are going to import our calendar table in a dynamic way. So what do you mean by dynamic? So dynamic means that the start date and the end date gets updated based on the other tables that is in place. So for example, in our data set, we have the dip table, right? And we have the stock table. So both of these tables has date fields, and you also have the start date and the end date, isn't it? So what we are going to do in our calendar table is that we are supposed to go to the dip table and take the start date, and also the end date is supposed to be dynamic. So what do you mean by dynamic? So these are highly transactional records where every day you have the dates getting added. So your calendar table will dynamically take the dates from your dip and the stock table. And how do we do that? So guys, creation of the table, there are multiple ways. So one is by using enter data, and another one by using a new table in order by writing a DAX expression. So let's see how to do both of that. So before we just jump into writing a DAX expression for a calendar table, even your fuel info table. So let's say how this fuel info table looks like. So quickly go to the table view, click on the fuel info table, and you will be able to see your fuel ID, the fuel type, and the name. So these information can also be typed. How do I do that? Go to the home tab, click on the enter data option here. So as soon as you do that, what happens is that a create table pop-up window appears. So here you can rename this column. So let's say I'm going to rename this column as fuel ID, and let's say I'm going to add another column. I can go ahead and add, let's say, type. Okay, and I can also add the rows, guys. So here I can add it as fuel ID can be 1, the type of the fuel can be petrol, and the next row, the fuel ID can be 2 and the type can be oil. So in our case, we've already imported the data, but this is just an option to show you guys the various methodologies that you can use in order to create a table. And you can also give it a good name to this table. So as I already have fuel info table, I'm just going to give name called as fuel. Okay, and I can directly load. So this is the most simplest way of creating a table. But the only drawback with this is that, so in our case, it just had 2 rows, right? So your fuel table is in place. It just has 2 rows, but let's say you have like 10 rows, 20 rows. So at that point of time, it becomes very cumbersome because you may end up, misspelling a couple of words, right? So always one of the major drawbacks of your enter data option is that, okay, what happens is that you may end up doing spelling mistakes, or you may also have to encounter, when it comes to lengthy tables, you feel that it's unnecessarily time consuming to type each and every information, right? So in cases like that, we go for writing a DAX expression. So the same table, fuel info table, can be replicated by using a DAX expression as well. So let me just make you understand what these different fields are about, okay? So if you just see here, you have this function called as data table. So data table is basically a function which is used to create a table. And the arguments that a data table takes is that you will have to mention the column names. So in our case, guys, your fuel type is your column 1, your fuel ID is a column 2, and the name of the fuel is a column 3. Got it? Now for every column, don't you think we have to assign a data type, which is very important? So this is the same thing that we were doing in our data transformation. So what I'll be doing here is that this thing that you see here, integer, is your data type. Okay, and so is your string. So this is a string, this is an integer, and again your name is nothing but string. So make sure that you choose the right data type. post which you have two curly braces. So every curly brace basically acts like a row. So here, as we have 3 columns, you have provided 3 values. So petrol belongs to column 1, which is a fuel type. 1 is nothing but the fuel ID. So that is the column 2, and your MS is nothing but the column 3, which is the name of the fuel. So in this manner, you can keep typing the number of columns that you want and the number of rows that you want to include. Again guys, this also becomes cumbersome if you have a very lengthy data set. Imagine if you have to insert 20 to 30 number of rows. So what happens in that case is that you'll probably end up missing any of the curly braces. So in situation like this, always go ahead and import data. So having it in an Excel format or a CSV format or even a text document can help you, right? If the data is available already. So let's try to quickly see how to get this fuel information table by typing DAX. So let's quickly go to our Power BI, okay? So you have to basically go to the table view, okay, and click on new table. So here is the expression that gets loaded, and here you will be typing the name of the table, that is fuel 2 in our case, and you will be creating an expression using the function data table. So if you see here data table, it is asking the name of the column followed by the type. So name 1, type 1. So you can give n number of names and types. So in our case, the name first, let me just give a fuel, okay, followed by the type. So as soon as I click on this, I have the list of data types that is available. So fuel will always be string, isn't it? So I can either go for text or string, that is fine. And you also have this particular red color mark here that is visible, which means I have opened the braces, round braces, and I have not closed it, okay? So these kind of errors you have to know. Next, comma separated. So let me quickly go to the next line. Let me give a proper indentation to this, right? So let me go to the next line and give it an ID. Okay, and ID will generally be an integer. Got it? So that's about the first argument that I gave to the data table. Post which I am going to open a round braces, okay, in which all the rows will be included, and in that I am going to first include the first row. So first row, double braces, it's going to be petrol, which is a fuel type, followed by the 1, which is the ID. Okay, close this. So this will basically attribute to my first row, followed by comma, and then open the round braces and let me give oil as my second row and ID as 2. And close it. Now that I have closed my both the rows, I can go ahead and close this curly braces, and I can go ahead and close the data table function. So this is a very simple DAX that you have learned first, that is in order to create a table. So click on enter. Do you see here? So you can also expand and collapse this accordingly. So you have the fuel followed by the ID. And what are the two types of fuel? Petrol and oil with the respective IDs. So that is the second way of creating a table. So let me just quickly go and delete both of this because that was just for a demonstration purpose. I'm also having to click the delete from model. Now let us try and understand how to create a calendar table. So how do I create the calendar table? Same thing, go and click on new table. So as soon as you do new table, a new table is created. So let's give it a name. So that is your calendar table. You can simply call it calendar as well. So for this table, we are going to go ahead and add columns, okay? Because we are trying to visualize the monthly sales, weekly sales, quarterly sales. So for these components, we need those columns in place. So which is why you're basically creating, or you're basically using the add columns method. So here the first function is going to be the calendar function. So in the calendar function, so this is basically the column that is first created, which takes the start date and the end date. As I told you, I want the start date and the end date based on our dip or stock. So you can choose either of them. So I'm going to choose dip. So it's going to be the minimum value that is present in the dip, which means the very first entry of the dip table, right? So it is minimum of the dip table ka date. So I'm going to click on that, close the min function, and then the end date is going to be the maximum of the dip date. So this again is going to change with the period of time, right? So that is why I've kept it dynamic. So here I'm also going to close the calendar function in place. Now next I'm going to go ahead and add columns. So firstly, I want the column called as week, right? So within the double braces, I'm going to go ahead and type in week, and there is a function called as week number, guys. So this function will extract the week number given the date. So here there is already a column that is added which contains date information as soon as you use the calendar table. So here I'm simply going to click on the date function, and I'm going to mention 2. 2, why? Because Monday, basically the week starts with 2, right? Which is why. So again, I'm going to close here. Okay. As for the third column, I'm going to call it month. Let's keep it caps. Okay. And the function is simple. It is month, for which I'm just simply going to pass this date function. All right. Post which, close this bracket. Let's have the quarter related information and the year related information. So let's go to the quarter. Okay, and let me type quarter. You already have the function in place, and within this I'm going to choose date. So that's about the quarter. And yearly information. Okay, and there is also a function called as year, which you can pass for this. Initially, you may find it a little difficult in getting a hang of how to write DAX, but once you understand the syntax, it's going to be really easy. So additionally, guys, I also need 3 other columns in place. So that is nothing but the month and the year, right? So the month year will basically give me the month as well as the year. So for this, we are going to use the format function. Reason being that we are supposed to get the month in MMM format and the Y in YYYY format. So I'm going to have to use this format function, for which I'll be using 2 parameter, guys. First one is the value. All of you know the value is date, followed by the format that you're looking out for. So as I earlier told, the format is going to be M followed by YYY. Close the format function. Got it? So that is going to fetch me the month as well as a year. Nextly, let me fetch the month name, because I do want in places where it is written as Jan, Feb, March, right? So in names like that, I want the month name. Okay, again, I'm simply going to format this. The formatting option is pretty simple. Just gonna pass date followed by the way that you wanted to format. So here I just want MMM format. So past that, I'm also going to want the quarter name, isn't it? So let me quickly type in quarter name, which is the name of the column, followed by the formatting option. So I'm going to have to format the quarter. So before we actually try to write the format, right, I'm going to have a Q followed by Q1, Q2, Q3, right? So I have to have Q in place, which is a capital Q, and post which I have to use an ampersand, which is used as a connector in order to connect the Q with the name of the format. And then I'm going to use the format function, open bracket, and I'm going to format the date, okay, as Q. Got it? So I think these many number of columns works fine. So let me just go ahead and close the add column function, right? So are we clear so far? All we have is we are going to have the month name, and followed by that we'll very soon see how these values look like. So once you click on enter, it's taking some time to process, and there you go. Guys, please observe that if you are making any mistakes, it will throw up an error and you will not be able to see this date related information. So again here automatically this particular column date is being formatted as date and time, which we will be changing. So if you just click on this particular column, you will be able to see that a column tool gets open, right? So here again, instead of the data type being date and time, you will be changing it to just the date. All right, again, it's long date. We'll have to format it as short date. Okay then, looks good. So that's your calendar table, guys, in which you have date, you have the week, the month related information, the quarter related information, the month and year, which is in the form of month followed by year, the month name and the quarter name. All right now, so let me try to explain in the next slide about the ambiguities that can happen if you do not have these dimension tables in your place. The reason that I'm going to tell this way ahead of visualization is that while we are creating visualization, it also becomes very important for you to understand the depth of why the dimension tables are that important, right? So let us say that we are going to create a simple slicer. Okay, so do not bother much about the settings. We'll be going in depth in the visualization chapter. This is just for your understanding. So try to focus on the concept. So click on this particular slicer here. So in the slicer, so let's say I were to visualize the date. Okay, so based on the date, I were to visualize the sales component. Okay, so let's say from our just assume that you do not have the dimension tables right now in picture, okay? So imagine you do not have the calendar table that you've just created. Let's say you just have the stock table, right? So what I'm going to do is I'm going to drag this date and place it here. So that's going to create a nice slicer for your date, okay? Followed by that, I'm going to create a simple column chart. And in this particular column chart, I'm going to place in x-axis, let's say, let me just go to the shift reading tables. So let me just take the location information. Yeah. So let's say location wise, I want to see the sales. Okay. So this is how it's going to look like. Now, earlier chapters, we did talk about the interactiveness, right? So let's say I want to change this. Isn't my visual actually supposed to change? But here nothing is happening. Why is that? The reason being, guys, I have chosen this date from stock table, isn't it? See, as soon as you click on the slicer, you will see a tick mark beside the tables, right? So which means that the element date is present from the stock table. But whereas if I click on this particular visual, that is a bar graph, you have the elements taken from the shift reading tables. So here is why your visual is not interactive. Have you actually established a connection between the dimension table or between stock and the shift table? We haven't, right? So this is a very reason why understanding the relationship and establishing connections is very important. Okay, so let me also show you how to rectify this. Simple, guys. Instead of just having your date in your stock, I'm just going to quickly take it and take the date parameter from the shift reading table. There you go. Now your bar graph is very much interactive. But do you think this is feasible? Because in my fuel bunk dashboard, I actually have a lot of visuals in place. So do you think that it is actually feasible where I take multiple parameters from multiple other sheets and try to put? No, that's definitely not. I would want to have one common placeholder in the slicer, wherein if I just change, all the other visuals get interacted, just like the one that I have here, right? So which is why we created dimension tables such as your calendar table, your fuel info table, and your fuel location info table. Got it? So now let us try to understand how to establish connection between these tables and make sense. Okay, so there you go. Let's start the modeling. Let us just keep our fact tables in the middle. So for simplicity of the explanation, I'm only going to consider the dip fact table followed by the stock fact table in the middle. Okay. Surrounded by that is your dimension table, like you have the calendar, okay, and then you have the fuel, followed by that you have the location information. Now, in order to establish connection, pay attention guys, one date can have multiple dip entries, right? So which means one entry corresponding in your calendar table can have multiple information pertaining to dip. Reason being, there are also multiple location that is involved, right? So let's say for the given date of, let's say 15 September. So for 15 September, I may have numerous number of entries because I also have Bangalore location in place, Hyderabad location in place, and Chennai location in place. Similarly, for one particular fuel type, I can have different stock related information. Why? Because the fuel, that is your petrol, is present in Bangalore as well. Even in Chennai, the same information is there, isn't it? So there is multiple repetition of your fuel information, right? Of your stock information in your fuel table. So this is a one-to-many relationship. Similarly, when you talk about your location, one location can have different dip entries and one location can also have different stock entries because the fuel type is different, isn't it? So if you actually look at this diagram, you have something called as, if you look at from calendar table to the dip, you have one-to-many relationship. This can also be a many-to-one relation, right? So why these kind of relationships are important? The reason being that here, just in the ambiguity example that I showed, I have to filter something based on the date, right? So let's say I want to filter some information based on September 23 till October 24. So this information will be taken from my calendar table, which has unique entries, right? So let's say I want to visualize sales related information from my shift table. So this table basically has repetitive entries, okay, based on this particular date table. So one particular information always comes from a dimension table and the many side of a relationship always comes from a fact table. So if you also look here, you see this one part of the relationship, it comes from the dimension table and the many part of the relationship actually flows into the fact table. Okay, now let's discuss another example guys. So you have stock table in place and then you also have the calendar table in place, and we know that the information always flows from the calendar table to the stock table. Reason being that calendar has unique values which is used to filter the information that is present in the stock table. That is how you can visualize date-wise, location-wise and fuel-wise information when it comes to sales or purchase or even expenses. Got that? So, I would also like to talk about one more thing. With respect to relationship, your one-to-many or many-to-one is not the only relationship. In our example, we are working on the many-to-one relationship. But sometimes you may also encounter relationships like this, that is many-to-many. Which means both the tables has the star, many to many. And even the direction of the filtering need not always be single. It could always be bidirectional. And you may also have one-to-one relationship. wherein one side of the relationship is present on both the tables. So let me just make you guys understand with respect to this many to many and one to one. So let's dive into this example, okay? As far as the many-to-many relationship is concerned, for simplicity's sake, I've only taken the cash collection table and the shift reading table, guys, okay? So let us say I have pump name, and let's say I want to visualize the sales based on the pump, or let's say I want to visualize the cash collection based on the pump name. So let me do one thing. I'm simply going to drag and drop it here. All right, so guys, this data modeling that we have done here, one to many, let's try to replicate that in our PBI. So let's just go to our interface. We have all this in place, just like the way we expected. Now, you're supposed to go to you're in the report view, right? You're supposed to go to the model view. In the model view, as soon as you open, what happens is that you may not see such a clean and organized report. You may see something where, all these reports are basically scattered this way, right? So in that case, all you have to do is just zoom out a little bit, okay? Zoom out just a sufficient time where you can actually see all the tables in one particular place, okay? And you also see certain relationship that is already created. So this is something that is automatically done by the Power BI. So in our case, let us just delete and start building everything from the scratch. Okay, right click and delete. So now, while you build a relationship, guys, it's highly recommended that you keep the fact table below and the dimension table above. The reason being that it will be easier for you to see the filter direction. Okay, so in our case, let's start with the calendar table. So just like the way that we discussed in PPT, what we are going to do here is date is a common information that is present in all the tables, isn't it? So I'm just going to click the date information in the calendar, drag and drop it to the dip information. Date information in the dip table. So if you actually see here, whenever you start creating a new relationship, this kind of a tab opens. So here you'll be able to see the date and date. So both this column should have identical data types, okay? And the column name can be different, okay? That doesn't matter. So instead of having date, you can have something like calendar date. That doesn't matter as long as the information is in the place. So here, cardinality is nothing but it is a relationship, okay? So here it's correctly chosen one to many relationship because one value in your calendar table can filter multiple value from your dip table, okay? And here the cross filter direction should always be kept single because the calendar table filters the dip table. So here make sure that make this relationship active is turned on and click on save. So once you do that, do you see a relationship is created, and whenever you hover through this, you can actually see the column that gets highlighted, and also if you see the filter direction, it is always downwards, okay? In case if you wish to delete this, you can simply right click and delete this, okay? And if you wish to alter any kind of properties, you can double click this and the relationship tab opens wherein you'll be allowed to edit, and here you can also check whichever column you want to. So in our case, it's all in place, so I'm going to delete it. So quickly, I'm going to do the same thing for all the other tables, wherein I'm going to link this date to the fuel rate ka date. Okay, so everything looks in place because here in our case, the model is well designed, right? We have been through this particular steps of data modeling and everything. So everything is working as planned. Okay, so the relationship is generated. Similarly, let's do another one. Yes, one to many. So I'm going to quickly finish doing the same for all the other relationships. Alright guys, so the relationship with the date is done. Similarly, I'm going to do for the fuel information as well. So here, just be mindful about checking the fuel type and the fuel name, because the alphabets needs to actually match, the spellings needs to match. So in the dip you also have a column called as tank fuel. So here you don't have the fuel type, you have the tank fuel, but it contains the same information, right? So I am simply going to click on the fuel type and the tank fuel here. So if you actually see here, the relationship is correct, okay? So make sure that you check on the right one and again save. So the same thing is going to get repeated. Just make sure that this direction is always single direction, because sometimes when you're creating too many relationships, you may get confused and you may make it bidirectional. So just make sure that doesn't happen. Okay, so again, see here, while dragging and dropping, by mistake it is chosen the fuel. No, it's correct. It is fuel type. So let's just go ahead with this one to many. Okay, fuel type with the fuel type. Okay. So again, the fuel information is not there in the expense in the cash. Reason being that you do not need the type of fuel in order to calculate your expense, or in order to make sure what is the amount of cash that is being generated, right? So let that be. So with respect to the location, of course, location information I think you need in all the other tables. So in a similar manner, I'm going to be doing that. So location from the cash collection table, I'm going to connect one to many. So here if you just see the location and the city should match. The location should match with the city, not the ID. Okay. So just update that relationship. Alright. And also you should not have any kind of this dotted line, guys. Let's just see why you're getting that. So from the cash table it is many, and the one side of the relationship is the location table. That's okay. Yeah. And also here if you see, do you see this dotted line, which means this is an inactive relationship and there is one active relationship. See, I have established location related information from here as well as here, right? So let me just quickly delete it. Let me try to do it again. Okay, now there you go. We are done with establishing all the one-to-many relationships. So if you actually look at this, kind of looks a little clumsy. So even if you want to resize or reshape, you can go ahead and do that. So just be informed that zoom out really helps, because initially if you're in the zoom in phase, right, it becomes very difficult for you to drag and drop. So I always prefer zooming out a little bit while working on the relationships, right? So guys, ideally this kind of schema is said to be a star schema. You may be wondering as to this doesn't nowhere looks like a star. So don't worry, there is another schema to complicate things a little bit more. Let me just show you this diagram. So if you actually see, for the simplicity's sake, right, I've just considered one dip table, right? So this is what we have done throughout our practical lab, and the filter direction is downwards. Okay, so ideally a star looks something like this. So you have the fact table in the middle, okay, followed by that you have the dimensional tables at the outer edge, everything interconnected to each other. So this kind of schema is called as a star schema, where your dimensional tables are denormalized. So what do you mean by denormalized? So denormalization is nothing but it is a process in which you do not have multiple dimension tables. So in our case, we only have one dimensional table in picture. So you only have calendar. You do not have, as you know that we do have the quarter related information, month related information, and we have everything in one particular dimension table. Similarly, even in the fuel categories also, we have it in one table. And even the location, guys, see, you can have multiple things like information pertaining to your store, like the store manager, or how many number of employees actually work in the store, who is the manager, who is the accountant. You can have all those information, but our schema is kept very simple. You only have location table as single, right? So which is why it is called as a star schema. The another schema in which your dimensional table can be normalized or have multiple dimension table is called as a snowflake schema. Okay, so if I just verbally explain, it can be a little confusing, which is why I have an example in place. Okay, so let us quickly go to this particular slide. Okay, so this is a slide where I would like to show the example of a snowflake. Now, kindly observe this location dimension table, guys. So, forget about the location dimension table that we just worked on because it's very simple. So, for snowflake, the problem comes when you have multiple columns in place. So, see here, you have the location ID, city, place. You also have the information pertaining to the store here and the store manager, the number of employees and the city manager. Got it? So, the issue comes here if you have to update any location. So, if I am basically running a fuel bunk, you might have seen it keeps changing, right? So, instead of Bangalore, let's say I am updating the location to Mangalore. So, this is again a very simple table where you hardly have just 6 rows. Okay, in reality, it's not going to be like that. You may have like 100 rows as well. But in our example, if we just have this many number of rows for the simplicity in explanation. So let's say I want to replace Bangalore with Mangalore. How many places do I have to update? I have to update here, here and n number of records that has Bangalore. Not only that, guys, I should also update this place information because obviously Mangalore is not going to have Indiranagar, right? So I'm supposed to update that as well. So this kind of updation creates redundancy in your record, isn't it? Which is a little difficult. Also, the whole purpose of dimension table is defeated if you have those many number of rows and columns, right? So, which is why in snowflake schema, you will be splitting this dimensional table into 2 halves, okay, which looks like this, okay. So, you have the location table here. So what I'm doing here is in the dimension table 1, just look at this particular table, dimension table 1, I'm retaining the store ID, I'm retaining the manager and the number of employees information, whereas the location is actually repetitive here, no issues. And I'm also having another dimension table which has information pertaining to the location, city and the manager. Also guys, this particular dimension table is linked to the dimension table 2 so that your location ID maps, right? So the mapping should already also be done. So here the table which looks like this, wherein let's say that I have stock table which is my fact table and I have one single dimension table pertaining to the store, will now look something like this, where I have one stock table but I have the dimension table 1 and the dimension table 2. And this is also mapped, right? So see the number of joins. So this is a snowflake schema because the dimensional table here are normalized, or rather having multiple sub-dimensional table. But there is also pros and cons to both of it. So let me talk about the pros of the snowflake schema. So you already know that the updation part of it. So earlier I had to update in multiple places, right? But now I just have to update in one single place. I have to update in one single table, where Bangalore, I just have to change it to Mangalore and I have to change the manager of the store. Good, because the redundancy is reduced to a lot of extension. But there is another disadvantage. The disadvantage is, so let's say I wish to get in stock, I have purchase related information, isn't it? So let's say I want to fetch the purchase liters of the stock based on the city. Okay, so in this earlier schema, I could just simply go here and fetch the stock related information based on the city because it's directly connected. But coming back to this, I have to actually pass through this, get to the location ID, and based on the location ID, I have to get to the city information and the manager information, which means the number of joins is obviously more, right? So here the complexity is more, yes. Why is the complexity more? Because the number of joins are more, yes. I'm using a lot of joins here, Okay, in our case, we just had 2. So just imagine you have 4 such tables, right? You have to do the mapping part of it also. You have to reference the tables. So that is going to slow down your system performance. Why? Because a place where my model had to just traverse one direction, now it will be traversing 2 directional. So slow down performance, as in your query time is also going to take a lot of time if you have to fetch any information. So these are the disadvantages of having a Snowflake schema. So generally not recommended for freshers, reason being that it will be really very confusing and time taking, right? So which is why we just go with a simple star schema. But again guys, it also depends on your business requirements. So sometimes what happens is that your client may want you to have certain information to protect the confidentiality, wherein one particular table cannot have all the information. So let's say you have certain personal contact information as well, right, which is obviously unique. So you cannot have all this information in one common table. So in things like that, you may have to go to the Snowflake. So just be smart enough during the earlier stages itself in order to detect what are the data types, what are the columns that can be normalized, so that you don't, what are the columns that can be harmonized in order to make sure you don't end up, in a very complicated schema, right? So to summarize, we did learn about relationships and cardinality, right? So we did learn about one-to-many, right? We'll also be going in depth in learning about many-to-many and one-to-n. I do have a couple of examples pertaining to our data set itself, but in this particular project, we are only going to learn about one-to-many. And we also spoke about the cross-filter direction, how it is a single direction. Post which, yes, we did discuss about schema. So schema is nothing but a structure or a blueprint, okay, of how the data is organized in the database, okay. So it is basically a structure. Your star schema is basically the blueprint of how you have corrected, connected and modeled all the data. And we did see the various differences between the star schema and the Snowflake schema as well. So in your star, your dimensions are denormalized, which means it's just kept simple. Whereas in your Snowflake schema, the dimensions are further normalized into subtables, which means it is broken down, right? Remember guys, only your dimensional tables are normalized and denormalized. Your facts remain the same because you obviously cannot meddle with the numeric information, isn't it? So that's what we just did. Now let's dive into understanding many-to-many relationship and one-to-one relationship. So for many-to-many relationship, consider an example, okay, where I have only taken the cash collection table and the shift reading table. The reason that I have chosen this table is, guys, do you see this pump name? It is common in both the tables, right? So let's say I want to visualize sales based on the pump name, correct? And also the cash that is collected on the pump name, because this is going to be simultaneously happening, right? In a fuel bunk, you will have different bunks and then you will have different people who are in charge of that bunks. So let's say I want to see which pump is actually performing better. So this can actually help in probably determining the direction that I can improve in which the vehicles are flowing, right? So here, if I were to establish a connection, I will simply be connecting the pump name and the pump name here. Okay, it's a simple connection, but see what happens here. Here, even in the cache, the pump name is repeated multiple times for the same location. And even in the shift reading, the pump name is repeated, isn't it? Again, the pump name will also have a dedicated fuel, okay? But it is not a unique entry that we have made. We do not have a separate dimensional table which can only store the pump related information, isn't it? So we do have this pump name common in your cache collection as well as your shift reading. So this kind of relationship can actually cause ambiguities in your model. So if I just go to OK, okay, because here I will not be able to select the filter direction. How can I tell if shift reading is going to filter the cache collection or whether the cache collection is going to filter the shift reading? So I cannot actually tell that. So because of which this is a relationship that is created, right? So this can also cause performance issues, guys. Also, while you're creating measures or creating aggregations, it can yield an inaccurate results and you will not even know what is going wrong. right? So the thumb rule is that you'll not be doing these kind of errors. So instead, what you will do is you will create something called as a bridge table. So what is a bridge table? Bridge table is nothing but, so in our case, you have something of this sort. So you have the stock table, okay, and then you have the cash table, okay. Okay, you have the shift reading table, no issues. Okay, and it is a many-to-many relationship, and the direction is also like cross filter. So what we'll do is we will break this relationship, okay, and we'll form a neutral table called as a bridge table. And in this bridge table, we will have only the pump name, because pump name is something that is common in both the tables, right? So you will have a one-to-many relationship where bridge table will basically filter the shift table, and even here you will have one-to-many relationship. So this is like an indirectional relationship, isn't it? So your issue is now solved. So this is what in industry standards we do. And how do we actually create bridge table? Again, you can just go ahead and you can check what are the names of the pumps and all that. How do I do that? I go to the table view and I simply do this. So these are the names of the pump. But I'll tell you one thing, what happens is that the naming conventions are really important, and if you just miss even a particular space or anything, again your results will differ. So let's not take that risk, okay? Let's do a very simple, let's write a simple DAX which is there to produce the results that is obtained by combining or a union of it and fetch only the distinct, okay? So what I'm going to do is a basic logic. I'm just going to do a union of these two tables, okay? So this plus this, I'm going to create a union, and I'm just going to create a distinct value on this union, okay? So that's how I'm going to write my measure. So let's start writing the measure, many to many, okay? So let's click on new table. Okay, and the DAX that I'm going to write here is, let me call it as pump bridge table. Or you can name it as bridge table also, pump bridge, okay. So let me start adding. So first I'm going to use distinct function, okay, followed by the distinct function, come down, let's do union. So union of what are the columns? So firstly you're going to select the cash collection table, right? So let us select the columns. Okay, so select columns has the table, the name and the expression. So the table here is a cash collection table and the name is nothing but the pump name, right? So that's the name of the column, right? Followed by the expression. So the expression is nothing but in the cash collection table you have something called as a pump name. So you're only going to take that, okay? So I'm just closing the select columns. So union should actually have two parameters, okay? That is the two tables that you're trying to join. So here I am supposed to mention the shift reading tables as well. So select column from what table? From the shift reading table. So I'm going to click on shift reading table and again the name is going to be the same, that is the pump name. Followed by that the expression. The expression is from shift reading table, right? So there you go. Okay, so I've closed the select columns, close the braces in the union function, close the distinct function and enter. So there you go guys, a table name called as a pump bridge is connected. If you have to see the parameters, do you see? Quick, so this is very quick. So in scenarios like this, I recommend do not type. Rather just get familiarized with DAX and just use the expression. Now let us just go back to the data model. Let us quickly bring this guy right in the middle here. And let us just connect the pump name and the pump name. So do you see here? It's a many to one relationship. It's clean and clear. So let me just say okay. And let us make another one to many relationship. All right then. So that's how you deal with many to many relationship. I also did speak about one to one relationship, isn't it? So Let me just take you to this example of 1 to 1. Okay, all right. Now just pay attention here, okay. So this is again a scenario where you have to handle some kind of an additional information. So let's say you want to have a tank related information also, where you're storing the height and the width. Where do you think this will come into place? In the dip, because when you dip in centimeter, right, based on your width of the tank and the length of the tank, you may have to calculate the stock in liters, right? But do you think this field keeps changing every day? No, right? Ideally, once you constructed, you will not disrupt the tank until and unless absolutely necessary. So in this case, you have a table called as a tank table. And you also have one dimensional table called as a calendar table and the stock table. So this is just for the relationship sake, guys. In the stock table, you have tank related information. So in this particular example here, I have connected the stock table with the tank table, okay, using a one-on-one relationship. Because in the stock, again, I just have 3 tanks, and in the tank table also I have 3 tanks. So what happens in these kind of scenarios? Additionally, there is an extra table, right? And you're just adding weight to the model because you're at the end of the day going to establish a connection, right? So this is particularly not required. So in industry, what they do is when there are too many one-to-one relationship, we go ahead and simply try to merge those tables. So now you'll basically have all the information in your stock table, which is also pertaining to your tank. You'll have the tank height, the tank width, and also the name. So remember guys, your one-to-one relationship, it is better that if your columns are merged, so that again your performance will also be good. So that's about it. So in this particular chapter, I think you're not only aware of the practical examples that we have learned so far in order to create a good, robust model, but you now also know the concepts that is involved, what you have to do when you encounter a many-to-many or a one-to-one. All right, let me see you in the next video. So that's the end of this video. Hope you liked it. Please share and subscribe, and thank you for watching. See you soon in the next video.